This lesson is on clinical significance. In a previous mini lesson, you learned about statistical significance and what that means. So hopefully you remember that statistical significance tells us how likely it is that the result you found happened by chance. The thing is, statistical significance is dependent on two things: sample size and the size of the difference you observe. So how big was your sample and how different were your groups? You'll remember this little graph we drew. Let's pretend this time that it's referring to a new hearing aid technology that's on the market. They claim to significantly improve speech perception and noise compared to the gold standard aids on the market. So they took a group of 40 people with the same hearing profile and had half wear the new hearing aids and half wear the old ones, then tested their speech perception and noise using the gold standard speech and noise test before and after being aided. So this is the difference between their scores on the test before and after being aided. On average, the group with the new aids got 35 more words right out of 100, compared to the other group that got 20 more words right out of 100. So they run the test, and here are the results. They get a p-value of 0.10. That's not significant. There's a big overlap between the groups. We just can't say that this finding wasn't due to chance. It might have just been by chance that there's that difference. Maybe there's no real difference between the two groups at all. But I don't know, the difference between 35 and 20 seems pretty big. So they decide to do the study again. This time they get 400 people, 200 in each group. The thing about big sample sizes is that it narrows your distribution. So there's fewer people out here at the ends. Now you can see there's less overlap here too. There's virtually none. The averages they found are exactly the same, but now since the sample size was so big and there was so little overlap, this same difference was now found to be statistically significant. You can imagine too, if they had a big enough sample size, if the average difference was only like 5 words apart, they could still find a really low p-value and would conclude that their results were statistically significant and that the hearing aids made a difference, even though the difference was so small. But is that small of a difference practically significant or clinically significant? Do we really care that these new fancy hearing aids can make people hear 5 more words on average out of 100? Does that really matter? If something is statistically significant, that doesn't mean it's clinically significant. In fact, it's really only one factor in clinical significance. Statistical significance is just about whether it's by chance or not. Clinical or practical significance refers to a finding's usefulness, its practical application in the real world, how valuable the evidence is in making an impact in patient care. Here's 2 important definitions for you. Efficacy is the impact of a treatment in a well-controlled environment. Effectiveness is the impact of a treatment in the real world. We need to be mindful about what a research article is testing. Efficacy is wonderful, but it only makes a difference clinically if it translates to effectiveness. There's so much more than a p-value that goes into your decisions about patient care. You need to think about things like whether or not the improvement observed by the new treatment is big enough to make a difference in your clinical practice. This is where effect size can come into play. Is 5 words out of 100 enough to make you recommend this new hearing aid? Is 10 more words enough? What's enough? Are there any negative side effects? Is there a great cost difference? Are these new hearing aids so much more expensive that no one could afford them anyway? How comfortable is the clinician in carrying out the new treatment? What are the patient's or caregiver perspectives? Is the hearing aid so huge that no one would wear it? So you have to think about all these aspects of clinical significance in addition to considering statistical significance when you're making decisions about patient care.